Hello everyone, good day. Welcome to the ACE online platform. I am Vivek Narsampalli. I will going to deal with the electromagnetic theories subject and which is targeted for the SSC JE exam. For the SSC JE exam, uh, if you observe the previous papers, 4 to, on the average, this may be variable, 4 to 6 questions are expected. If you do some research on the previous papers, these are conclusions you can draw. Fine, okay. So this is for the subject electromagnetic fields. Now concepts are very simple, very straightforward. Theoretical questions are asked. Some numerical questions are also there. Fine. So now let us, what we will do here, this is all about the syllabus. This is all about the weightage. Now let us focus on the syllabus here. Syllabus is very simple. It's a very short and very sweet. Topic number 1 is a electrostatics. Topic number 2 is a magnetostatics. Topic number 3 is a time varying fields. Okay. So in the electrostatics is the study of charge which is at the rest. Okay. Suppose if you have a charge and around the charge, from your basic physics you know that there is an electric field around that. If I keep this charge under the motion constitutes the current, and the current carrying conductor will have a magnetic field around it. So the electrostatics is the study of charge which is at the rest, and the magnetostatics is the study of charge which is under the motion. Time varying field is, it is a study of charge which is accelerated or deaccelerated. Okay, fine. So in this session, we are going to focus on some topics which are related to the electrostatics. Fine. So let us start our discussion with the topic number 1, electrostatics. Let me turn the page here. Topic number 1, electrostatics. So as I said earlier, what is electrostatics? Electrostatics is the study of charge which is at the rest. Fine. So here in the electrostatics, we'll talk about the charges. We'll talk about the point charge, we'll talk about the line charge, we'll talk about the surface charge, we'll talk about the volume charge, different types of charges. That means charge distribution may happen over the line, charge may be a point charge distribution may happen over the line, may happen over the sheet, may happen inside the volume. Okay, yes. So these are the different charge distributions. And we're going to define we're going to talk about in the electrostatics, electric force. From your fundamental physics, you know that if there are two charges are there, there will be a force of attraction or repulsion between them. So we'll talk about electric force, we'll talk about electric field, we'll talk about flux, flux density, Gauss law, potential, capacitor. Okay, so these are the topics which are there in the electrostatics. I'll repeat again. Different types of charges, point charge, line charge, surface charge, volume charge, force between the two charges, and definition of the electric field, and the electric field due to the various charge distributions, and the flux, flux density, Gauss law, potential and capacitor. Fine. So in this session, I'll going to focus on what is called electric force and electric field. Two topics will focus. Fine. Let me turn the page here. So we're going to start your electrostatics. As you all know, your electrostatics will going to start with what is called a Coulomb's law. Okay, you have been learning this one from your high school physics. We'll reiterate the same thing here, the Coulomb's law. What does the Coulomb's law talks about? The Coulomb's law talks about the force between two charges. Okay, charge is a property of a material, you can say. Okay, so there are different types of charges. One is a positive charge, other one is there are two types of charges. One is a positive charge, other one is a negative charge. Fine. As you all know, from your high school physics, you would have learned the same thing we are having here. If there are like charges are there, what I have written here, what is the Coulomb's law is stating is a very simple thing. Let us focus on this. Like charges repel each other and unlike charges attract each other. Like charges repel each other. That means positive charges will repel each other. They'll repel. Positive. Negative also repel. Positive or negative positive will going to attract. So that is what this first statement is saying. Like charges repel each other, like charges, and unlike charges attract each other. Okay, fine. Next one, what is the, then that means between the two charges there exists a force, whether it could be attraction force or repulsion force. Okay, both kind of forces are can be noticed. Fine. Then what is that magnitude of the force here between the two charges? That is also given by the Coulomb himself. What Coulomb's law says is this one: the force between two charges is proportional to the product of the charges and inversely proportional to the square of the distance between them. Okay, so as I said earlier, there are two charges are there. Between those two charges there is a force, whether it could be attraction force or repulsion force. Then what is the magnitude of the force according to the Coulomb's law is product of charges. Let me turn the page here. I'll show some diagram here. Let us consider the two charges here. I'm considering the two charges. Here is the first charge Q1, here it is the second charge Q2, and the distance between these two things is a R. Clear? Yes? So, this is a Q1 charge, this is a Q2 charge. They may be a positive charges, both may be positive charges, both may be negative charges, positive negative or negative positive. And there is a distance between them. What is the distance between them? R is the distance between them. Fine. Suppose if these two are positive charges, what happens? They'll repel each other. The force will be like this. If they are positive charges, that means like charges. If they are both are negative charges, then also they repel each other. If they are positive, negative, negative, positive, they'll attract each other. Fine. Okay. So what is this? What is the force between these two things? I can say force on this due to this, or force on this due to that. The magnitude of the force will be same. So what is the magnitude of the force between the two charges? I'm going to give this one as F. According to the Coulomb's law, what it is saying is the magnitude of the force. Actually, the force is a vector. We are writing only the magnitude. What is the magnitude of the force between these two things? Here it is Q1. According to this Coulomb's law, let me go back to the Coulomb's law, what he has mentioned. Read out the second statement. This is a law actually. The force between two charges is proportional to product of the charges and inversely proportional to the square of the distance between them. Okay, so the force between these two charges is proportional to product of the charges Q1, Q2, and it is also proportional to square of the distance between them. Okay, that means if more charges, if you consider the more charge value, there is a possibility for there will be a more force between them, whether it could be attraction or repulsion. That depends on the nature of the charge. Okay, friends, fine. And one more thing, the force between the two charges is inversely proportional to the square of the distance between them. Suppose if I increase the distance between the two charges, what happens? The force will going to fall down. Okay, fine. So it is inversely proportional. It is practically observed. It is experimentally observed by the Coulomb himself. Okay, then one can argue, why can't it be 1 by R? Why can't it be 1 by R cube? Why it is only 1 by R square? Remember, it is purely out of practical observation. It was observed by the Coulomb himself. Fine? Okay, now let me combine these two things here. I'll combine these two equations. So I can write this one as F is proportional to Q1 into Q2 divided by R square. Okay, fine. And obviously there is some proportionality constant here. The proportionality constant is 1 by 4 pi epsilon into Q1 into Q2 divided by R square. This is a proportionality constant. 1 by 4 pi epsilon, or you can also write this one as simply F is equal to Q1 Q2 divided by 4 pi epsilon R square. Remember, what are the units for the force? Just we are writing the magnitude, not the vector. Okay, that means vector means what? The force on this one. Suppose if these two are positive charges, force on this one will be like this. And what is the force on this one due to this one will be like this. Okay, fine. So this is the force between the two charges. This is the of force between the two charges. Clear? Okay. Then what about this epsilon here? That is called permittivity. What it is? Permittivity. Let me write down here itself. So what is this epsilon? Epsilon is equal to epsilon naught epsilon r. Okay. So what this epsilon is called? Epsilon is called permittivity. And what is this epsilon naught? Epsilon naught is equal to 1 by 36 pi into 10 to the power of 9 farad per meter. This is called absolute permittivity. I'll talk about these things. Let me write down first. This is absolute permittivity. Okay. And what is this epsilon r? This is called relative permittivity. Relative permittivity. And what is this epsilon r value? Epsilon r value is equal to 1 for the air, and it is greater than 1, remember this point, for other than air, something like a glass, other than air. So for the air, epsilon r is equal to 1. If epsilon r is equal to 1, what is this epsilon is equal to? Epsilon naught epsilon r, where epsilon r value is 1. And one more point, what are the units for this epsilon naught? It is the farad per meter, very important, you must remember this. And what is this epsilon r? Has got no units. This is also important point, need to be remembered. Okay, fine. Then what is this permittivity? It is a medium parameter. What it is? It is a medium parameter. Let me put this one in a simple way. Actually, that epsilon I need to define with respect to some material. It depends on the polarization, polarizability, yes, and all those things are there. But just for our understanding, here under the context of this Coulomb's law, this epsilon itself is a separate discussion. We will not go into that. But let me put this one into the simple words. What is this epsilon? Epsilon is electric force allowability of the medium. Okay, how well the medium can allow the electric force through it, or electric field, later we will discuss the electric field through it. How easy the medium is, how well the medium can allow the electric field or electric force to pass through it is described by the epsilon. Or let me put some other words, how the medium is behaving to the electric force. Why? Because these two charges are there, right? In between these two charges, where you are placing these charges also important. Are you placing these two charges in the air, or in the sea water, or inside the water, or you can place these two charges inside the glass, isn't it? In which medium they are existing, that is also will going to decide the what is called the force between them. Okay, so what are the force between the two charges is dependent on product of the charges, and it is inverse proportional to the square of the distance between them. Along with that, there is one more point, because why I am stretching this point, on this concept there was a question. Fine. So along with that, you can also notice that the force between the two charges is also dependent on the medium in which you are placing those two charges. Fine. Okay. So that medium is characterized, is defined by this epsilon. Epsilon is equal to epsilon naught epsilon r. Okay, fine. You must remember this value, 1 by 36 pi into 10 to the power of 9 farad per meter. Okay, friends. And epsilon r value is equal to 1 for the air, and epsilon r is greater than 1 for other than air. Fine. And what are the units here? Farad per meter. All these things are very important. Fine. Now let us take some questions here to appreciate these concepts what we have learned so far. Concepts are very simple. Okay, fine. Let me turn the page here. Yes, this was one of your previous questions. Observe how it is. Coulomb's law for the force between the electric charges closely resembles with. The Coulomb's law is something similar to what you would have learnt in your high school physics. Is similar to what? Newton's law of motion, law of conservation of energy, Gauss theory, Newton's law of gravitation. It is something like a Newton law of gravitation. What is this Coulomb's law is talking about? And there is one famous meme, memes are also there in the internet, you can check out. Some will say that the Gauss has copied. There are some famous jokes also there. Some will say that the Gauss has copied this Coulomb has copied this Coulomb's law from the Newton. Why? Because what Newton talks about? Newton talks about the force between, gravitational force between, or force between two masses, two objects which are having some mass m1 and m2. And the Coulomb law is talking about the two bodies which are having a charge q1 and q2, and it talks about the force between them. Okay, something similar here. Let me write down. Just I'll recall your basics. Suppose two bodies are there. Here it is mass m1. Here it is m2. The force between these two things is, distance between these two things is r. What is the force between these two things? Some constant g into m1 m2 by r square. Yes or not? Just now what we have seen, suppose if you consider the two charges, here it is q1, here it is q2, r. What is the force between these two things? Just now we have seen 1 by 4 pi epsilon into q1 q2 by r square. Something similar. There is a resemblance. There is a similarity between the two charges and two objects which are between the two objects which are having a mass m1 and m2. Here is the two charges. They are having a charge. They are two bodies. They are having a charge q1 and q2. Here something similar. There is a gravitational. There is a proportionality constant. Just forget about this one. m1 m2 by r square. Here q1 q2 by r square. Clear, friends? Okay. So there is a famous joke. The people will say that the Coulomb has copied this law from the Gauss. Okay, fine. See here. This was one of your previous question. Yes. So what is the answer here? Here it is the Newton's law. It is, you will find some similarity or resemblance here. Newton's law is the answer. Okay, let me turn the page here. Let us have one more question. Yes, read out this question. Very fundamental questions are asked. Here also previous question. The electrons revolve the nucleus with high velocity. Which type of force acts against the centrifugal force and keeps the electron in their orbit? What is the centrifugal and centripetal force? Centrifugal and centripetal. This was my big confusion during my school days. Centrifugal and centripetal. What is centrifugal and centripetal? Suppose if some body is revolving. What is the centripetal? The force which acts towards the center. Petal. Remember the rose petals. How the rose petals, one of my teacher told this example. I asked you to remember me with the rose petals. Or how the petals will be? Rose petals will be like this. So, what it is? It is a centripetal force is towards the center. Centrifugal force is away from the center. Yes, as we all know that if you want to keep that body rotating, so the centripetal force and the centrifugal force must be same. Okay, fine. So let me explain this one with the help of simple example. Here is a solution. We know the atomic structure. There is a nucleus here, positively charged one, and there is an electron here which is revolving around this. Here is an electron, is revolving around this. As it is revolving, it can revolve only when the central petal and centrifugal force are balanced. Yes, so as it is revolving, obviously there will be what is called a centrifugal force. Away from the center there will be a force, and this must be balanced with the other force. So nucleus is positively charged one, this electron is negatively charged one. There is a force between these two things. What is that force? Electrostatic force. Yes, so what is the force here? It is the electrostatic force of attraction, because positive and negative charges are there. Nucleus is a positive, electron is negative. Between those two things there will be attraction force. So what is the answer here? Centripetal force, centrifugal force must be equated, must be balanced with the centrifugal. What is the centrifugal? It is the electrostatic force of attraction. Option A is the answer. Okay, fine. Let us take one more question. Here is a question. Yes, a small numerical. A charge 8.85 into 10 to the power of minus 9 coulombs is located in a vacuum at 2, 3, 1, and another charge of 4 pi into 10 to the power of minus 3 coulombs is located at 2, 2, 1. The magnitude of the force between the charge is. Excuse.
Full length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program.
I am Vinit Kumar. I have secured All India Rank 1 in Mechanical Engineering in ESC 2021. I have been associated with ACE Engineering. I have taken various programs like Lives, main classes, postal study course, test series and interview guidance program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in test series, I have given various mock tests which have helped me in the time of real exam, and in interview guidance program, building confidence.
Okay. So, it is asking what is the force, what is the magnitude of force between the two charges. What is the magnitude of the, you have to use this Coulomb's law. Fine. Here is the solution. There are two charges here. How much is the charge? One charge is 8.85 into 10 to the power of minus 9. The other charge is 4 pi into 10 to the power of minus 3 coulombs. And what is the distance between them? This charge is at 2, 3, 1. This is 2, 2, 1. Is asking what is the force between them. Fine. What is the force between the two charges? Which is given by Q1 into Q2 divided by 4 pi epsilon into R square. He said it for the vacuum. That means for the air. For the air, what happens? We know that epsilon is equal to epsilon naught epsilon R. For the air, epsilon R is equal to 1. So, which is equal to epsilon naught. What is this epsilon naught value? It is 1 by 36 pi into 10 to the power of 9. And there is other way of, there is one more way also there, one more value also there, you must remember. 8.854 into 10 to the power of minus 12. Okay, fine. Just substitute all the values here. I am going to turn the page here. So what is the force between the two charges? F. Q1 into Q2. What is the Q1? It is 8.85 into 10 to the power of minus 9 into 4 pi into 10 to the power of minus 3 divided by 4 pi into epsilon naught value. What is the epsilon naught value? 8.854 into 10 to the power of minus 12. So just take it as a 8.85 into 10 to the power of minus 12 into distance square. How do you find out the distance between 2 points? 2 minus 2, it is 0. 2 minus 3, it is minus. It is 0 square plus 2 minus 3, it is minus 1 square plus 1 minus 1 is 0. It is 0 square. So it is 1 square, square root is 1. Fine. So what happened? This part, 4 pi will go. Here it is 10 to the power of minus, the numerator will become 10 to the power of minus 12 divided by 4 pi, everything will go 10 to the power of minus 12. So it is 1 Newton is the answer. 1 Newton is the answer. Yes, simple substitution kind of question. Here it is 1 Newton. Option A is the answer. Okay, friends, let us have one more question. Okay, read out this question. This was also one of your previous question. Two charges are placed at some distance apart. Okay, if the glass slab is placed between them, the force between the charges will. Simple. You need to remember this. You can all deal with all these things just by the Coulomb's law. There are two charges are there, Q1 and Q2. They are displaced at a distance of r. Okay, friends? Fine. If the glass slab is placed between them, that means initially nothing was there. That means it is a air. So the first case, here there air is there. So epsilon is equal to epsilon naught. Epsilon is equal to epsilon naught. And later, you are introduced what is called a glass slab. Here it is Q1, here it is Q2. What is epsilon? Is equal to epsilon naught epsilon r, where epsilon r is greater than 1. Here epsilon r for the air, nothing is there means air, epsilon r is equal to 1. So obviously, this dielectric constant, the glass permittivity will be greater than permittivity of the air. Fine. So what is the force here? Force between these two charges? It is, we know that force between the two charges. Let me write down here. The force between the two charges is equal to Q1, Q2 divided by 4 pi epsilon r square. Here, the force is inversely proportional to 1 by epsilon naught. Here, force is inversely proportional to 1 by epsilon naught epsilon r. So here the denominator has increased. So what happens to this one? This force will going to decrease. Fine. So here epsilon r, this has increased. So this will going to reduce this value. So decreases. Clear, friends? Okay. So the force between the two charges will going to decrease because of introducing this glass. Fine. Let us take one more question. Yes, this is also one of your previous question. I'll just read out. Which one of the following statements about the force between the two charges is true? What is true? Is asking what is true. Unlike charges repel each other. Unlike means what? Positive, negative, repel each other. Wrong statement. Like charges attract each other. Wrong statement. Positive, positive, negative, negative. No. No force exists between the two unlike charges. Wrong statement. A force of repulsion exists between the two like charges. Like charges. So, this is a correct statement. Option D is the correct. Okay, friends, fine. So these are the some of the varieties of questions. Number of times questions was noticed from this Coulomb's law. You can easily answer them if you can remember these statements and if you can remember this law, this expression. Fine. Now let us have, as I said earlier, we are going to focus on this electric field, or it is also called electric field intensity. It is represented with the E. Okay. So if you consider the two charges here, I have indicated something differently. If you consider the two charges, q charge and small q charge, and there exists a distance here, they are displaced at a distance of r, then what is the force between them? What is the force between them? F is equal to q into q divided by 4 pi epsilon r square. I will bring this charge q here. F by q is equal to q divided by 4 pi epsilon r square. Force per unit charge. What are the units here? Newton per Coulomb. Force per unit charge, this is called electric field. This is represented with the E. E is equal to q divided by 4 pi epsilon r square. Units are Coulomb per Newton per Coulomb, or there are other units also there. You will know this one after getting the potential concept. Volt per meter. What is more important is a volt per meter. You need to remember the units. There will be questions even on the units also. The units of the electric field is Newton per Coulomb, other units are volt per meter. These are very popular. Okay. So how do you define the electric field? Force experienced per unit charge is called electric field. What it is? Force experienced per electric force. Electric force experienced per unit charge. Newton per Coulomb or volt per meter. Clear, friends? Okay. I should add one more point here. For the positive charge, let me add one point. Suppose, for example, let us take one example here. Suppose if it is a positively charged one, for a positive charge, for a positively charged one, here I mean positive charge, electric field is outwards. If it is a negatively charged one, radially outwards, radially inwards. You have to remember these things. Suppose if it is a negatively charged one. So here the electric field is radially outwards. Radially outwards, radially outwards, radially outwards. Okay, yes. So how the electric field is here? It is radially outward. Radially inwards. Radially inwards, radially inwards, radially inwards, radially inwards. Radially inwards, radially inwards, radially inwards. So what you have to remember here, due to point charge, how the electric field is, here it is radially outwards due to positive charge, radially outwards. Here it is radially inwards. Okay, fine. Simple. Let me go back here. So everything, rest of the things are same. Epsilon is there, R is there, Q is there, everything is there. So how the mathematical it is defined as force per unit charge, force experienced per unit charge. That means here, if there is a charge is there, suppose if there would have some unit charge here, what is the force on force? What is the force direction? In this way. Suppose if there would have some unit charge, the force direction is in this way. Suppose if there would have some unit charge, the force direction is in this way. Suppose if there would have a unit charge, the force direction is in this way. Suppose if there would have a unit charge, the force direction is in this way. Like this, and so on. Suppose if there would have unit charge here, the force direction is in this way, in this way, in this way for the negative charge. So in short, what you will call is, suppose if it is a positively charged one, electric field lines are outwards. If it is a negatively charged one, electric field lines are inwards. Okay friends, fine. Let us take some questions here to appreciate these concepts. Here is a question. When the electric field, dielectric placed in an electric field, the field strength decreases. The story remains the same here. The same question was asked under the context of electric force, and here there is an electric field. See here, here is a solution. There is a charge here, nothing is there. That means here the medium is epsilon is equal to epsilon naught. What is the electric field strength? Electric field is equal to Q by 4 pi epsilon r square. It is inversely proportional to 1 by epsilon beta. Yes, nothing is there here, so the electric field is inversely proportional to 1 by epsilon naught. Suppose suddenly in the second case, this is the first case. In the second case, you are having epsilon is equal to epsilon naught epsilon r. So what happens to the electric field is 1 by epsilon naught epsilon r. Obviously epsilon r will be greater than 1 for other than air. Dielectric, something like a glass, something like a mica. Okay, fine. So here what you have noticed here is a denominator has increased. So now this will going to decrease. Fine. So as it has increased, this will going to decrease. Means what? Decreases. Option B is answer. Okay friends, fine. So let us take one more question. Here is a question. The electric field from A to B will be. This was one of your previous question. See here, that means on this one, the charge is Q and you are moving from A to B. That means the distance is increasing. So if the distance increases, what happens to that? That means this entire thing is a charge. That is how you have to assume. How much is the charge on that? How much is the charge on that? Q is a charge and you are moving from A to B, from here to here. So you are increasing the distance. Suppose if you increase the distance, what is the electric field expression I have given? E is equal to Q divided by 4 pi epsilon r square 1 by r square. So electric field is inversely proportional to 1 by r square. Clear? Fine. Now here distance is increasing, electric field strength decreases. So what is the answer? Option B is the answer. Okay, fine. Let us have one more question. Here is a question. Yes, it is a numerical based question. The electric field intensity at a point situated 4 meters from a point charge is 200 Newton per Coulomb. 200 Newton per Coulomb. If the distance is reduced to 2, the field intensity will be. Okay, let us take the question here. Let us draw some rough diagram. So there is some charge here. At a distance of 4 kilometers. So not 4 kilometers, just 4 meters. The electric field is, I'll call this as a E1, is 200 Newton per Coulomb. And is asking at a Q, it is 2 meters. What is the electric field E2? How the electric field is related to the distance? We know that electric field E is equal to Q by 4 pi epsilon r square. That is 1 by r square. Okay, fine. So how this is how you can write this one? Here it is E 1 by E2 is equal to R2 by R1. Or otherwise you can also write in other way. E2 by E1 is equal to R1 by R2. What is E2? It is, I can bring this 200 other side, R2 square here into R1. What is R1? R1 is 4 meters. R2 is 2 whole square. Yes. So here it is 2 square. 200 into 2 square, it is 4. So what is this E2? E2 is equal to 800 Newton per Coulomb is the answer. If the distance is decreased, obviously electric field strength increases. Okay, so what is the answer here? The answer here is 800 Newton per Coulomb. What is the answer? Option C is the answer. Okay friends, let us have one more question. The direction of electric field due to positive charge. Away from the charge, isn't it? Suppose if it is a positively charged one, electric field lines are away from this one, radially outwards. Okay. Suppose if it is a negatively charged, that is radially inwards. Let me go back, I have given this explanation already. So how the electric field is defined? Force per unit charge. So there is a charge here, suppose positive charge is there, suppose if I would have one more charge here, positive charge, what happens? Unit charge, the force will be like this, away from this one. We'll go into exert force on that. So in this direction. Suppose if there would have a charge here, the force on that one is in this way. That means electric field is like this. So this is a negatively charged one. Suppose if there would have some charge here, the force on that one will be towards this one. Fine. That means for the positive charge, electric field lines are outwards. For the negative charge, electric field lines are inwards. Fine. So here it is away from the charge. Okay. Let us have one more question. Yes. Something interesting question. It's not from the SSC JE, it is from the KPTCL, Karnataka state exam. Okay. In the above, that means in the below diagram, the magnitude of the electric field at a point A is E. A is E. What is the electric field at a point B in terms of E? So the electric field, here is a charge is there, this is a charge q is given here. So here electric field is given, is asking what is the electric field at B in terms of A. So this is the first unit, second unit, third unit, fourth unit, isn't it? Okay, you can write this one as some 1, 2, then 3 for our understanding. Okay, fine. So here I'll call this as a electric field E1 is equal to E. Is asking what is electric field E2. What is the electric field here E? E is equal to Q by, how it is related to the distance? Electric field E is equal to Q by 4 pi epsilon r square. This one is 1 by r square. So we know that is asking for E2 by E1, which is equal to R1 by R2. So E2 is equal to E1. How much is the E1? E1 is nothing but a E into R1. How much is the R1 here? The R1 is of 1 unit. R2 is a 3 units. Okay. So here it is R1 is 1 unit. Square here, no, don't forget this, there is a square. R1 is 1 unit, R2 is a 3 units. Whole square. So how much is this? Here it is. One unit. So E2 is equal to E divided by 9 is the answer. So E divided by 1 by 9 into E is the answer. So option A is the answer. Okay. So now let me do some fast recapitulation here, what we have done so far. We have introduced a very simple concepts here in this session, but they are important. Number of times questions was noticed in the previous papers. You can easily handle these kind of questions, isn't it? Because you are aware of these concepts from your high school physics also. So here this is the syllabus, electrostatics, magnetostatics and time varying fields. And then here is the electrostatics. It is a study of charge which is at the rest. Okay, fine. We have started about what is called a Coulomb's law. What is a Coulomb's law is? A Coulomb's law is talks about the force between the two charges. If they are like charges, they will repel each other. If they are unlike charges, they will attract each other. Fine. And what is the force of attraction or repulsion between them? It is proportional to the product of the charges, and it is inverse proportional to the square of the distance between them. And if you combine these two things, you can write this one as F is proportional to Q1 Q2 by R square. And the proportionality constant is 1 by 4 pi epsilon Q1 Q2 by R square. Okay. What is this epsilon? The force between the two charges is dependent on the magnitude of the charges and the distance between them, and also on the medium parameter. Clear? So what is this epsilon? Is a medium parameter. Epsilon is equal to epsilon naught epsilon r. Epsilon naught is called absolute permittivity. Epsilon r is a relative permittivity. Epsilon r value is 1 for the air, and it is greater than 1 for other than air. Okay, fine. So it is something looking like a, you will find a lot of in the social media, you will find a lot of memes on these things, that people say that Coulomb has copied from the gravitational Newton's, isn't it? Newton talks about the force between the two bodies which are having a mass m1 and m2. The Coulomb talks about the force between the two charges which are having a charge q1 and q2. Okay, fine. These are the varieties of questions. And then we have introduced the concept of electric field, or it is also called electric field intensity. One should remember its units. What are the units? Newton per Coulomb or volt per meter. Other units are. How it is defined? Force per unit charge. What it is? Force per unit charge is called electric field. Okay, fine. Now, suppose if it is a positively charged one, the electric field lines are outwards. Yes, that means how the electric field lines are assumed. Suppose if there would have a charge here, how it is defined? Force experienced per unit charge. Suppose if there would have a charge here, What is the force on that? In that manner. Suppose if there would have a charge here, what is the force on that? In this manner, because they are attracting. Because negative charge here, if I place it some positive charge, the force will be like this. That means electric field is like this. So final conclusion is, suppose if it is a positively charged one, electric field lines are radially outwards. If it is a negatively charged one, electric field lines are radially inwards. Fine. These are the varieties of questions. Okay, fine. Just a second. In this session, we have focused on this electric force and electric field. Fine. So this is all about this session. Hope you're all going to make the ACE online platform as a part of your success story. For the more videos, please do subscribe to ACE online platform. Download the ACE online app. Thank you.
From civil engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program.
I am Vinit Kumar. I have secured All India Rank 1 in Mechanical Engineering in ESC 2021. I have been associated with ACE Engineering. I have taken various programs like Lives, main classes, postal study course, test series and interview guidance program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in test series, I have given various mock tests which have helped me in the time of real exam, and in interview guidance program, building confidence in front of interview panel. It has helped me in my success.
Myself Abhishek Kumar Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now I divide my preparation strategy into three basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you.
My name is Coulomb. I have done my BTech from Ambedkar Institute of Technology, which is situated in Delhi, and I have secured All India Rank 1 in ESC 2021 from E&T branch. I took ACE Postal Course, Mains Test Series and Interview Guidance Program in ESC 2020 and ESC 2021.
Hello everyone, my name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program.
I am Vinit Kumar. I have secured All India Rank 1 in Mechanical Engineering in ESC 2021. I have been associated with ACE Engineering. I have taken various programs like Lives, main classes, postal study course, test series and interview guidance program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in test series, I have given various mock tests which have helped me in the time of real exam, and in interview guidance program, building confidence in front of interview panel. It has helped me in my success.
Myself, Abhishek Kumar Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now, I divide my preparation strategy into three basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you.
My name is Coulomb. I have done my BTech from Ambedkar Institute of Technology, which is situated in Delhi, and I have secured All India Rank 1 in ESC 2021 from E&T branch. I took ACE postal course, mains test series and interview guidance program in ESC 2020 and ESC 2021.
Hello everyone, my name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program.
I am Vinit Kumar. I have secured All India Rank 1 in Mechanical Engineering in ESC 2021. I have been associated with ACE Engineering. I have taken various programs like Lives, main classes, postal study course, test series and interview guidance program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in test series, I have given various mock tests which have helped me in the time of real exam, and in interview guidance program, building confidence in front of interview panel. It has helped me in my success.
Myself, Abhishek Kumar Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now, I divide my preparation strategy into three basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you.
My name is Coulomb. I have done my BTech from Ambedkar Institute of Technology, which is situated in Delhi, and I have secured All India Rank 1 in ESC 2021 from E&T branch. I took ACE postal course, mains test series and interview guidance program in ESC 2020 and ESC 2021.
Hello everyone, my name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering